Am I audible and the screen is visible? Let me know.
Yes, sir.
Okay. Okay, in this class, we will start the design of circular bunker. We have completed the design of square bunker, and it is also similar to the rectangular bunker. Only, the bending moment formula will be different for the rectangular bunker. Okay, we will start the design of circular bunker. Design of circular bunker. Okay, so the circular bunker. It is similar to the circular water tank. And the circular water tank or the circular bunker are subjected to hoop tension, are subjected to hoop tension. They are not subjected to bending moment. They are subjected to hoop tension. Okay, so we need to find the reinforcement for the developed hoop tension in the bunker. So hoop tension is given by, I will tell you, hoop tension. Hoop tension is given by T equal to pH. pH is the lateral pressure, and we need to find pH from the Rankine's formula. Whatever formula we have seen in the previous discussion, the same formula we need to use for calculation of pH. So T, what is T? T is hoop tension. T equal to pH into D, diameter of the bunker divided by 2. Then, the side wall. Here also we need to design the side wall and hopper bottom. See, in any bunker for that matter, in any bunker, you need to do the design of two elements. One is the side wall and other is the hopper bottom. Okay. So here side walls are subjected to hook tension only. Side wall is not subjected to bending moment. Side wall is not subjected to any other kind of forces. It is only subjected to hook tension. Side walls are subjected to hook tension only. Hook tension only. Whatever reinforcement we will be providing in the side wall, it is only for the hook tension. Okay. Here also we need to provide the distribution steel, and the distribution steel will be in vertical direction. Okay. How we have provided distribution steel in the square bunker in the same way, in the same fashion, here also distribution steel has to be provided. Okay. Distribution steel, distribution steel in vertical direction, in vertical direction. Okay. Distribution steel in the vertical direction. Hopper bottom. What hopper bottom is subjected to? Hopper bottom is subjected to two forces. One is direct tension and the other is hook tension. Okay. Hopper bottom is subjected to two forces. Hopper bottom, that is sloping slab, it is subjected to two forces. Hopper bottom subjected to subjected to direct tension and hook tension and hook tension due to normal pressure. Due to normal pressure. Normal pressure. Okay. Okay. One more thing we will define here. That is minimum thickness of the bunker. We have not seen in the previous case. The minimum thickness of the bunker should be 120 mm. minimum thickness of bunker is 120 mm. You can provide 120 mm or more than 120 mm, but not less than 120 mm. So these things we need to see. The side walls are only subjected to hook tension. Okay. The side wall will be designed for the hook tension, and the hopper bottom will be designed for direct tension as well as hook tension. Okay. So we will see these things in the problem. So here we have a problem. Design a circular bunker. Design a circular bunker to store 300 kilonewton load of the material. Use M20 and Fe415. The density of the material is given as 8 kilonewton per meter cube. Phi, the angle of repose is given as 25 degree. Coefficient of friction is given. Okay, but in case of bunker, we are not considering friction. In case of silos, because the silos are the larger beams, silos are larger than the bunker. So depth of the silos is more as compared to the bunker. If depth of the silos is more, in that case we will consider the frictional force. But here we will not consider frictional forces. Then also they have given. I don't know why they have given the problem, but we will not consider frictional force in case of bunker. Okay, they have given you ignore. Okay, coefficient of friction is this is university problem. Coefficient of friction. Coefficient of friction between coal. The material that to be stored is coal. Between coal and concrete is mu dash equal to 0.444. So this is what is given. So step number one, solution. Okay. Step number one, we need to fix the dimension of the bunker first. That is your step number one. Fix the dimension of the bunker. Dimensions of the bunker. Okay. Total weight of the bunker, total weight of the coal to be retained. Which material we need to store? Which material we need to store? The coal we need to store, okay? And the weight of the coal is given to you, 300 kilonewton. So I will write here, total weight of the material, total weight of the coal need to be retained, to be retained, to be retained means to be stored equal to 300 kilonewton, 300 kilonewton, okay? And this bunker is looking like this. This is how the bunker will look like. Even the circular bunker will look like this. So this portion is known as, the portion in the green color is known as surcharge. This is surcharge. Upper part of the bunker, okay? Or you store, more material, and the material will form shape like this. The material will form triangular shape. and that part is called surcharge. Okay, and the surcharge is having some angle. Surcharge is like this, it's angular shape, and it is having some angle. This angle is equal to phi. Okay, whatever angle they have given, the angle of repose. So the angle of surcharge is equal to the angle of repose. So this angle is given to us. This angle is, what is this angle? This angle is 25 degree. Okay. Can we find H1? I will take this as H1. This is my H1. Okay. And the middle part of the bunker is just like a cylindrical circle. The middle part, okay, that is H1. That is H1, and this is H2. The middle part of the bunker is H2, and the depth of the hopper bottom is H3. So how to find H1? Since it is a circular bunker, so the bottom part will be the diameter. It will not be square. In previous case, it was square, but here the bottom portion will be, the diameter of the bunker. Diameter of the bunker will be denoted as capital D. Okay. So how we can find this H? So from here to here, it is D by 2. So I can take tan phi equal to H1 divided by D by 2, opposite by adjacent. If I can divide the triangle, it will be like this. Opposite is H1 and adjacent is D by. Okay. So H1 equal to tan phi into D by. And what is tan phi? Tan phi D by 2 into tan 25. This is your H1. Okay. And this is just like a cone. If you see the surcharge, if you want to find the volume of the surcharge, it is just like a cone. If I can draw in 3D, it will be like this. It will be like this. Okay. It is just like a conical shape, just like a conical shape. And from the geometry how to find the volume of conical shape, how to find the volume of such figures. So volume of such figure, V1 is volume of surcharge. Volume of surcharge equal to half, not half, 1 by 3 into pi into R1 square, radius of the, radius of the bunker into H1. So what is H1? H1 is D by 2 in tan 25. And what is R1? R1 is also D by 2, half of the diameter. Radius is equal to half of the diameter. Okay. So V1 equal to 1 by 3 into pi into what is radius? Radius is D by 2, D by 2 square, D by 2 square into H1. What is H1? Already we have written H1 in terms of D by 2 into tan 25. So what we will do here, we will assume the diameter. Okay, we will adopt the value of the diameter of the bunker. You can adopt any value between 3 and 4. It depends on you. Okay. So I will adopt the diameter of the bunker as adopt diameter capital D equal to 3.5 meter. So this is 3.5 meter. What will be H1? H1 equal to D by 2 into tan 25 and D is 3.5. You can substitute the value of D and H1 will be equal to 0.82 meter. So we got the height of the surcharge. See, first step is, fix the dimension of the bunker. We need to fix the dimension of the bunker. So in that we have gotten H1. So once we have gotten H1, we can find the volume of the surcharge. Similarly, we can find H2 and H3 and we will get the volume of, other part of the bunker. So what is V1? V1 equal to, we can find V1. V1 equal to 1 by 3 into pi into diameter is 3 by 2, 3 by 3.5 by 2 whole square into h1. Okay, h1 is 0.82, which is equal to V1 is equal to 2.63 meter cube. 2.63 meter cube. Okay, so this is the volume of surcharge that we have gotten. So what is the total volume? Once you know the weight, total weight that needs to be retained, you can find the total volume of the bunker. The total volume of the bunker is denoted by capital V. Capital V is equal to V1 plus V2 plus V3. And what is V1? V1 is the volume of the surcharge. And what is V2? V2 is the volume of the middle portion of the bunker. And V3 is the volume of the hopper bottom. So we need to find the total volume of the bunker first. But we have gotten the volume of the surcharge, and then we can find the total volume of the bunker. So how you will get total volume of the bunker? Total weight that need to be retained. Total weight of the material So from that you can find the volume of the bunker. Okay. So volume of the bunker, volume of bunker of the bunker equal to weight that need to be retained divided by density of the material. Okay, so you know this formula, weight equal to volume into density. So from that formula, we are finding the weight. We are finding the volume. Weight is 300 kilonewton divided by density is 8 kilonewton per meter cube. Okay, so the total volume that of the bunker that we are getting as 37.5 meter
हेलो
cube. हेलो हाँ
सर,
यस
आपका आवाज नहीं आ रहा है।
आवाज नहीं आ रहा
आ
है
रहा है, आ रहा है सर।
आ रहे सर, बराबर आ
आवाज
रहे हैं।
आ रहा है बराबर
आ रहे सर, आ रहे।
दूसरों को आ रहा है
ये सर बराबर आ रहे
लेकिन
हैं।
आपके पास कुछ प्रॉब्लम रहेगा देखो अभी आ रहा है क्या
बराबर आ रहा है सर, पहले से ही।
यस सर, अभी आ रहा है।
आ रहा है ना ठीक है ठीक ठीक ओके so the volume of the bunker that we have gotten is 37.5 meter cube okay let the hopper bottom be at 45 degree the angle of the hopper bottom is 45 degree and the opening see the hopper bottom is like this is the hopper bottom and it is also in conical shape because the top portion is you know 3.5 meter in diameter and the bottom opening will also be in circular. The dimension of the opening is 0.5 meter. We'll assume 0.5 meter. The same we have assumed in the previous problem. And the top portion is 3.5 meter. And the angle of the hopper bottom is 5 degree. Okay. Can you find x3 from this dimension? Can anyone tell me how to find x3? Any one of you? Already we have discussed this. Let me know how to find x3. What is x3? x3 is the height of the hopper bottom. Can anyone tell me how to find x3? Angle is given to you, the above dimension and the below
cos
dimension is
45।
also. By using cos 45, that's okay. But how you will find x3? See, I can continue this.
एरिया ऑफ ट्रेपेजियम।
Area of trapezium, no. See, it is like this. I will tell you. This is your x3. So this dimension and this dimension will be equal. Am I right? Because the angle is 45 degree. The horizontal distance and the vertical distance will be equal. Am I right? Right or wrong? Since angle is 45 degree, the horizontal distance, this horizontal distance and this vertical distance will be same. So how you will find this horizontal distance? 3.5 minus 0.5 divided by 2. Am I right?
Yes, sir.
Yes, sir. 1.5.
Okay, so this horizontal distance and this vertical distance is same. So H3 is 1.5. Okay, but you know how to find the volume of hopper bottom? That is bit complex. See, to find the volume of hopper bottom, we will consider the conical shape, entire conical shape. So this depth will be 1.75 and this depth will be 0.25. Okay, so what I will do, I will find the total volume of this conical shape, and I will minus this much volume. So what I will get? I will get the volume of the hopper bottom. Am I right? What I will do, I will find the volume of the entire conical shape, and then I will find the volume of this small portion, and then I will minus this. So what you will get? You will get the volume of the hopper bottom. Am I right?
सर 1.75 कहाँ से आया?
1.75, क्योंकि देखो ये यहाँ से यहाँ तक का डिस्टेंस क्या है? 3.5 डिवाइडेड बाय 2 ना। तो ये डिस्टेंस और
यस सर।
वर्टिकल डिस्टेंस सेम रहेगा ना आपका, क्योंकि एंगल आपका 45 डिग्री है। और यहाँ पे भी देखो ये डिस्टेंस आपको कितना है, यहाँ से यहाँ तक 0.25 है ना, क्योंकि टोटल 0.5 है, तो 0.5 और ये 0.25 सेम रहेगा।
सर 3.5 माइनस 0.5 डिवाइड बाय 2 है ना?
3.5 माइनस 0.5 डिवाइड, इसका है वो, इसका डिस्टेंस है यहाँ से यहाँ तक,
अच्छा
टोटल
हाँ,
नहीं,
ओके।
टोटल अलग है। मैं टोटल की बात कर रहा हूँ यहाँ पे, ठीक है। तो हम क्या करेंगे, पहले पूरा जो कॉनिकल शेप है उसका वॉल्यूम फाइंड करेंगे, और उसमें से जो जो छोटा पोर्शन है वॉल्यूम फाइंड करेंगे, दोनों को माइनस करेंगे। जब दोनों को आप माइनस करोगे तो आपको किसका वॉल्यूम मिलेगा? आपको हॉपर बॉटम का वॉल्यूम मिल जाएगा। आ रहा है समझ में क्या कर रहा हूँ मैं?
यस
हेलो,
सर।
ओके। सो V3 equal to वॉल्यूम ऑफ द एंटायर कॉनिकल शेप पाई इनटू डायमीटर। यहाँ पे क्या रहेगा? डायमीटर यहाँ पे D/2, 3.5 डिवाइडेड बाय 2 स्क्वायर इंटू हाइट क्या रहेगा? 1.75। ठीक है, इसका इसका वॉल्यूम है, ये इसका वॉल्यूम है। इसमें डायमीटर क्या है आपका? डायमीटर 3.5 है, इसका वॉल्यूम है, माइनस दिस वॉल्यूम, इसका वॉल्यूम 1.3 इंटू पाई इंटू यहाँ डायमीटर क्या है? 0.5 डिवाइडेड बाय 2 स्क्वायर इंटू हाइट क्या है यहाँ पे? हाइट यहाँ पे 0.25 है। So, by deducting uh, this and this, you will get the volume of hopper bottom. Volume of hopper bottom equal to 5.60 meter cube. Okay, so what will be the V2? V2 equal to capital V minus V1 minus V2. Sorry, minus V3. So what we have gotten? We have gotten V1. V1 हमने find किया, और उसके बाद हमने V3 find किया। What is V3? V3 is the volume of hopper bottom. And what is V2? V2 is the volume of the middle portion of the bunker. That is the cylindrical portion. Okay. So you will get by this formula, you will get the value of V2. V2 equal to capital V we have calculated. Capital V is 37.5 minus V1 is 2.63 minus V3 is 5.0. So V2 will be equal to 29.27 meter cube. Okay. So once you know V2, see we have what we are doing. We are fixing the dimension of the bunker, and
हेलो सर।
simultaneously, yes, Hasif.
सर ट्रेपेजॉइड का डायरेक्ट फॉर्मूला क्यों नहीं लगाते? उससे थोड़ा छोटा हो जाएगा ना। तो आंसर क्योंकि मैंने चेक किया अभी क्रॉस चेक तो सेम आता है सर 3 आ रहा है उसका
अच्छा ना, ट्रेपेजियम का भी फॉर्मूला
30 आ
लगा
रहा है
सकते हो, लगा सकते हो, कोई इश्यू नहीं है। ट्रेपेजियम का भी लगा सकते हैं, ऐसे भी फाइंड कर सकते हैं। आपको ज्योमेट्री दिख रहा है ना, उसको वॉल्यूम फाइंड करना है, बस ये। ओके, so we got H1, we got H3. How to find H2? To find H2, we should know V2, and we know V2. What is V2? V2 is the volume of the cylindrical portion. The volume of the cylindrical portion. Okay, so we got V2. So from V2 we can find H2. So what is the V2? V2 equal to area pi r square, pi r square, pi r square into H2. What is the diameter? Diameter is 3.5 meter. Pi into r square is 3.5 divided by 2 whole square into H2. And what is V2? V2 is 29.27. So by equating this, you will get H2 is equal to 3.04, and you can take up to 3.1 meter. You have increased the volume, you have increased the value of V2. Okay. So again, you need to find the total volume. So total volume equal to, because you have changed H2, you have increased H2. Since you have increased H2, volume will also be increased. So again, you need to find the volume. From that volume, again, you need to find the weight of the material. Weight of the material will also be increased because volume is increased. So total volume of coal retained, total volume of coal retained, total volume of coal retained equal to V1 is not changed, 2.63. V2 is changed because H2 is changed, pi into r square. R square is 3.5 by 2 whole square into H2. What is H2? H2 is 3.1 plus V3 is not changed, 5.60. So total volume is 38.06 meter cube. This is the total volume that has to be retained. And again, we need to find the weight because volume is changed. Total weight equal to, weight equal to volume into density. Okay, because volume equal to weight by density. So weight will be equal to volume into density. Volume is 38.06 into density is 8. So this is coming 304.44 kilonewton. Okay, so we have fixed the dimension of the bunker. Next is the design of cylindrical wall or side wall. Design of side wall. That is your second, step 2. Step number 2, design of side wall. Design of side wall. I told you side wall is only subject to hook tension. So we will, calculate the reinforcement for the hook tension, and distribution steel is also to be provided in the side wall. That will be in the vertical direction. Okay. So horizontal pressure, you know how to find the horizontal pressure from the Rankines formula. We know that horizontal pressure PH equal to gamma H into cos square phi. Here H is H2. Remember, whatever H2 we have gotten, that is H here. We are not taking the height of the surcharge and height of the upper bottom. We are only taking the height of the middle portion. 8 into 3.1 into cos square 25. Okay, so this you're getting it as 20.37 kilonewton per meter square. Okay, so the formula of hook tension, I have already given you the formula of hook tension. Hook tension T equal to PH into capital D divided by 2. Okay, pH is here 20 into 3 4.37 into capital D 3.5 divided by 2. The hook tension that you're getting as 35.65 kilonewton. So this is your hook tension and it need to be factored. We need TU, factored tension. TU equal to 1.5 into T, 1.5 into 1.5 into 35.65, that is equal to 53.47 kilonewton. Okay, and you know how to find the reinforcement for the tension, for the direct tension and for the hook tension. We have the formula AST equal to TU divided by 0.87 into Fy. TU is 53.47 into 10 to the power 3 divided by 0.87 into 415. Okay, so AST you're getting it as 148.09 mm square. Okay, so we have to check whether this AST that we have calculated, is it more than AST minimum or not? We need to check that. So here also AST minimum, this is also just like a slab. Okay, the design of bunker is just like a design of slab. AST minimum for the slab or for the bunker is 0.12% of B into capital D. Okay, so we don't know the depth of, we don't know the thickness side wall. You can assume the thickness of the side wall. So here I will take 140 mm thick, 140 mm thick side wall. Okay. And B is, when we are designing the slab, we are assuming 1 meter width of the slab. Here also we will take 1 meter width of the bunker, 1 meter width of the side. So 0.12 divided by 100 into 1000 into capital D is 140 mm. So this you're getting it as 168 mm square. So whatever AST you have gotten, it is less than AST minimum. So you cannot provide 148 mm. You have to provide 168 mm square. Okay. So I will provide 168 mm square because that is minimum reinforcement that need to be provided in the bunker. So I will assume 8 mm bar, and the spacing formula, B into area of 1 bar divided by AST. You know the formula. So if I am assuming 8 mm bar, so my spacing is 299.19. 299.19, and the maximum spacing is 3 into D or 300 mm. So whatever spacing I have gotten, it is less than 300 mm. So we can provide that spacing. So I will write the statement here. Provide 8 mm bar at the rate 290 mm center to center. This is the horizontal reinforcement, okay, for hook tension. or hook tension in the horizontal direction. In the horizontal direction. Okay, so you see, we have gotten in the side wall. This is your side wall, and we have calculated the horizontal reinforcement. But you know, the vertical reinforcement is also the minimum reinforcement. You know, the vertical reinforcement is called as distribution bars. And what is distribution bar? It is also the minimum reinforcement. So when you find the distribution bar, you have to use AST minimum, and the AST minimum will be equal to 168 mm square. You will get the same reinforcement. Okay, directly you can write provide 8 mm bar at the rate 290 mm 290 mm center to center as distribution bars, distribution steel, as distribution steel, distribution steel in vertical direction. In vertical direction. You got this? Okay, so next we have the design of hopper bottom. We will discuss that in the next class. Any question you have, class? We have done the design of sidewall. Circular bunker is very easy as compared to design of square or rectangular bunker. We have done with the design of sidewall. In the next class, we will design the hopper bottom. Any question you have, class? Up to whatever we have discussed, you have any question?
No, sir.
Okay, you can share your attendance. You can just call your names. I will repeat your name, and next person can call his name.
Hasib Alekar.
Hasib Alikar.
सर वो
Then
हुक टेंशन
next,
वाला, ये हुक टेंशन जो कैलकुलेट किया था वो वाला स्टेप बताओ
कौन
थोड़ा
सा?
ऊपर। हुक टेंशन जिसने निकाले है, यही डिजाइन ऑफ साइड
Okay,
वॉल में।
एक मिनट।
हाँ यही।
हाँ, जल्दी बताओ, जल्दी बताओ। ये वाला ना? क्या हुआ? कोई क्वेश्चन है इसमें?
नहीं वो मिस हो गया था वो स्टेप में।
अच्छा, ठीक है, ठीक, कोई बात। मिस हो गया तो वो रिकॉर्डिंग देख लेना, रिकॉर्डिंग शेयर कर दूंगा। मुझे अटेंडेंस शेयर करो, वापस से शेयर करो।
ओके सर।
दानिश,
दानिश,
बुरहान।
अब्दुल्ला,
बुरहान।
हम्म।
नेक्स्ट,
Hasib.
अब्दुल्ला पटेल,
अब्दुल्ला पटेल। नेक्स्ट, और ये है, इतने ही लोग हैं?
सुल्तान
Sir Armash. Hasib, sir. Hasib.
हसीब, हाँ। उसके बाद अरमाश, और कौन है?
सुल्तान सुल्तान
सुल्तान, हाँ, सुल्तान है।
ठीक है।
ठीक है, इतने लोग हैं ना? और कोई बचा है? और कोई बचा है क्या?
हेलो,
हेलो।